Hello everyone and welcome back. Now that we are introduced the basic concept of charge and current from section 1.3, it's the time to apply what we have learned by solving practice problem 1.1, 1.2 and 1.3 from the textbook. This problem will help us to understand how to calculate the charge from the current over the time and the relationship between current and electric charge, I is equal to dq over dt, and apply integration and differentiation in real electrical situation. Let's solve them together and strengthen our understanding of this fundamental topic. The first example is this. Calculate the amount of charge represented by 6.667 billion proton. First of all, we should know that the number of electrons is equal to the number of protons. And also, we should know that the one coulombs had 24 times 10 to the power of 18 electrons. So, when we are talking about 6.667 billion, we are saying that we have 6.667 times 10 to the power of 9 electron. Therefore, we can easily find x as the number of protons that we have over 6.24 times 10 to the power of 80, which is equal to 1.0681 times 10 to the power of minus 9 coulombs. This is the amount of charge represented by this amount of proton. The second question says that calculate the current at t equal to 1 second if the total charge, which we show with q, is equal to 10 minus 10 e minus 2t. So, in order to find current, we know that current is equal to dq over dt, taking the derivative respect to t. So taking derivative of the constant is going to be 0 minus 10 minus 2 times e minus 2t. Therefore, I is equal to 20 e minus 2t. It says that I want I at time 1, so which is equal to e to the power of e rather than t. I put 1, which is minus 2. If you calculate this one, and since in the question is given, if I'm not mistaken, this one is millicoulomb. The unit of this one is in millicoulomb. This is telling me that this should be equal to 2.707 milliampere. And the last question, it says that the current following an element is as follows. When current is between 0 second and 1 second, it's constant with 4 ampere. And if current is greater than 1 second, then is 4t squared. At this point, we want to calculate the charge entering to the element. So we know that in order to find Q, total charge, we can say that it is equal to the current I dt. So, but we have two scenarios. The first scenario is when current is between 0 and 1, which is equal to 4 ampere. And I'm going to take the integration with respect to t. And secondly, we are going to see what if the current greater than 1. But the question is also says that calculate the charge entering of the element from, this is the missing part, from t equal to 0 to t equal to 2. So from 0 to 1, we are considering this one. From 1 to 2, we should consider this one, which is 4t squared dt. So therefore, what is q? Q is going to be the integration of dt is t 4t, and it is going from 0 to 1 plus 4 over 3 t squared as t changes from 1 to 2. So the first one is giving me 4, and the second one is 4 over 3. If it is 2, it is 8, and if it is 1, it's minus 1. Therefore, I have 4 plus 4 over 3 times 7, or 4 plus 28 over 3, which gives me 13.30 coulombs. Great work. We just walked through the practice problems 1 to 1.3, and now we've seen how to apply the definition of current and charge in the actual calculation. If you find this one helpful, don't forget to like, subscribe, and leave a comment if you have question or want more practice. Thanks for watching, and I will see you in the next video.